we're going to look at a two-proportion z-test. This is corresponding to the step-by-step example in your books on page 513. So here's the situation. There was a sleep study done, and they measured a number of people and measured if they recorded if they snored or not. The data, it was from a random sample of 1,010 U.S. adults. They were surveyed in 2002 by the Sleep in America poll. Of these, of the 1,010, 995 responded to the question about snoring, and they indicated whether or not they snored at least a few nights a week in the past year. So this is really, is it random or not? That's one of the biggest questions, and you're going to have to assume that it is, since that's one of our basic assumptions. It's simply a survey, and they wanted to know, they recorded their age, and they recorded if they snored at least a few times a week over the past year or so. And so if we're going to look at, we're just going to take phantom, and we're going to explore through that. And so I've written the question down. Are snoring rates of the two age groups really different? And so you've got the younger group compared to the older group, and the question is, as you get older, am I supposed to snore more? And so they're going to take two different age groups, and we're going to do a significance test, and we're going to determine if that, by using our p-value, if these groups are similar or not. And so we'll go ahead, since our phantom, that's going to be our p, basically. That's what we're going to be really asking. The hypotheses. We are in two sample proportions, and so we're really going to be looking at writing two sample proportions. So my HO, so my null hypothesis, starts out, and I'm going to say it in words, but I'm going to write it in symbols. It says, we believe that there is no difference between the groups. And so my HO would be, I'm going to write it in two different ways. It's the proportion of, we'll just say, old minus the proportion of young should be 0. So if we subtracted P of old and P of young, and they're the same number, then the difference should be nothing. They should be exactly the same. HA, for the same scenario, is going to be P of old minus P of young. In this case, now you have to be very careful about writing your null and alternatives with two samples, because the way that you subtract this, the way that I state, well, I'm going to subtract one way or the other way, it's going to make a big difference in terms of what am I looking at. Am I looking at a positive number, or am I looking at a negative number? In this case, we believe that as you get older, then typically you're going to snore, but that's the question they're trying to ask. So we're going to play this one safe, and we're simply going to say, is there a difference in the young group and the old group? I'm not going to say that you're more likely to snore when you're old, because that would be assuming a little too much for this particular problem. So it's always safe to play the not equal to alternative, and that's what we're going to go with. Now let me make another note out here. Another way of writing this, so this is like version 2, could be your HO could say P of old is equal to P of young. Okay, HA would be P of old is just not equal to P of young. It's probably more common to see it written as the difference, but both are perfectly applicable, both are perfectly acceptable. Okay, PHA. Let's look at our assumptions and our conditions. Now, just for the sake of the video and writing, I'm not going to write out all of the things that I say. but it's clearly labeled and written on page 514 in your book. And so let's just kind of go down the list. Independence is the first one we look at. Okay, so independence. In this case, it was a National Sleep Foundation that selected their people at random. So I believe that the independence assumption is satisfied, because if one person's snoring, then some random other person isn't going to be snoring because this person's snoring. So independence is good. Let's look at randomization. Randomization is really about, were they representative of the population? Now, these were almost, by definition, they told you that it was random. They randomly selected so many by telephone, by number, and they stratified it by sex and region. And so you've got two groups here that we're just going to assume were random enough. This is going to be a good representation of my population. Next one is 10%. 10% condition. You're looking at, I believe that there was a total of, it was 995 total people. And so if we multiply that times 10, 9,950. And so you're thinking there's definitely more than 10,000 adults in this particular group. So we definitely have less than 10% of the population. Okay, here's our new one, independent groups. And this is going to always be around when you're looking at your two sample situations. What we don't want to happen is we don't want the young group to influence the older group. If that's the case, then you have probably more like a matched pairs design. Your independence would fail, and you would not be able to continue on doing a two sample or a two proportion z-test. It wouldn't hold up. Okay, so in this case we're good on independence. The younger group isn't going to have an influence over the older group. They were selected at random, so that's all good. Okay, the last one we have is success or failure. So in this case, we have, let me give you the information for this one. The first thing we had in the younger group, we had 48 to snore. This is young. In the old, we had exactly, 318 to snore. In the younger group, we had 136 that did not. If you think about what I'm doing, I'm actually just telling you how many snored and how many didn't snore. The success or failure condition, remember, says that it's n times p and n times q have to both be greater than 10. But what is n times p? N times p is the number of successes, which is, in this case, that many people are snoring. And n times q would be the number of people that don't snore. So I'm just actually writing down the totals for each group. And let's see, we had 493 that did not. And so in either case, success or failure has been perfectly satisfied, so we're good on both those counts. So if we're looking at all our all our assumptions and conditions, we have 1, 2, 3, 4, 5 different things to check. Because all these satisfied, we can use a normal model, and we're going to perform a two-sample z-proportion test. So let's go back and so we're going to go back to, that was PHAN. We'll name our test. So this is going to be a actually it's probably more like two proportion z-test, what they call it, two prop z-test. It's proportions because we're in categorical data. We're looking at people if they snore or if they don't snore. and because we have two groups. We're looking at old group versus a younger group. Okay, so now we have to go to PHANT, our test statistic. In this case, most likely you're going to go to your calculator to create this data. We are going to look at pool data because we do believe that it came from pretty much, we're assuming that they're the same. So assuming that they're the same kind of says that our data should be pooled. I'm going to go ahead and just write this down and just to try to save time. So our pool standard, let me write the standard error first. So standard error for pooled is equal to 0.3, oops, got missing a 0.039375, just in case you need all those decimals. Okay, and so let's see where we're going to get our z-score. We're going to work that out in our test statistics. So this would be our z-score. Z would equal, once I calculate that, if you do the test, the z-score is one of your answers that they give you. So we have a z-score of 3.33. Now, at this point, I know that I'm going to reject the null because if we're looking at normal distributions, then when things are more than 2 standard deviations away, we call that an unusual event. This is even more extreme. It's more than 3 standard deviations, so we're looking at something that is extremely unlikely to occur. My p-value is probably going to be really, really close to 0 in this case. And so, test statistic, let's see, PHANTO, our p-value, out of your p-value, out of your test, it would look like this. Z-score is greater than 3.33. And I really should say it's more like an absolute value here. What we're doing is, I'll draw the curve in just a minute. We're really looking at above and below the curve. So this p-value that I'm about to give you is actually a combined probability. So you add the area at the top plus the area at the bottom. Now you don't have to worry about this because your calculator takes care of this for you, but it's 0.00, how many zeros is that? That's 3 zeros, 8, so really, really, really small. Let me draw this picture to kind of make sure we are all on the same page. And so you've got a normal curve. Here's our mean. So here's my 3.33 and negative 3.33. So now that's the z-score. That's not the actual proportion, so these are z's. The actual proportion, I believe, is 0.131 at the top. So what we're looking at, we're adding up the area here and here. Because this was two-sided test, we know that the total sum is going to be 0.0008. Okay, M. This is conclusion. I'm going to summarize here. So listen as we go through this. So we're going to definitely reject. We reject the null hypothesis. I'm going to be real short in the video, but definitely listen to the explanation. The p-value is really small here. So if there really was no difference in the old group versus the younger group, then the difference that we reported in this particular group, and the difference in their values, which was 0.131, we should see that occur in studies like this about 8 times in every 10,000 samples. So that's extremely small. That's very unlikely to occur. So we're going to reject the null hypothesis that there is no difference and conclude that there's a difference between older adults and younger adults when it comes to snoring. And in fact, judging from my results, it would appear that older adults are more likely to snore because their proportion was a lot higher than the younger one. Now, if you wanted to really nail this down and really put forth a lot more evidence, then at this stage I would conduct a 2 proportion z interval and find out exactly where does that interval fall. Does it fall all above 0? In that case, you would be looking at positive difference. If you're looking at does it all fall below 0, then you would be looking at a negative difference. We know that 0 is not going to fall inside that interval because we're rejecting the null. And so if everything's above it, that means everything that you would do, 95 or 100% or whatever your confidence level is, say 95%, of those samples would all generate a positive difference, which means the older adults are always going to have the larger number, always going to have the larger percentage of people snoring. And so when you create that confidence interval, it gives you more evidence, more ammunition to say, well, I'm not just sure that it's different. Look at the interval. The entire interval is above, or the entire interval is below, and that's going to signify a little bit more to what your difference really is going to be most of the time. So here's Phantom for a 2-sample t-test, or 2-sample z proportion test. Make sure that you are checking each one of these pieces and going through the whole test and writing out your conclusions effectively.